circuit analysis or circuit theory or electrical circuit analysis. In this video, we see AC circuits, average value, and RMS value, and that is 2021 regulations, and 9 is it is syllabus, first unit. Kindly noted. That is third unit for Dote syllabus. Kindly noted. Anna University syllabus, first unit. And Dote syllabus, third unit. Kindly noted that is AC circuit basics in this video. AC circuits, general term, average and RMS value of current and EMF in this video seen. Sine waveform, that is AC waveform, EMF generator versus graph WT. Induced EMF E is equal to EM sine omega t. Generated EMF E is EM sine theta. Generator shown in figure north and south pole and commutator center in positions. Commutator produces the induced EMF. We operate maximum EM is 90 degree and the minus maximum EMF is 270 degree. 180 degree, that is pi. 360 degree, that is 2 pi. We operate is 0 value. That is important. E is called instantaneous value. E is not constant but varies instant to instant. EMF is the maximum value. EMF can attain. EMF is the maximum value. EMF can attain. So it is called maximum value or peak value. From graph when theta is 0 degree, E is theta. Apply E is EM sine theta. Theta is 90 degree or pi by 2. E is capital EM. Theta is 180 degree. E is 0 degree. Theta is 270 degree. E is minus E maximum. Apply E is EM sine theta formula. Theta is 360 degree. E is 0. In this way, we obtain regular sine waveform of AC currents, AC circuits. Mean value or average value, graph shown in figure. That is current versus time. I1, I2, I3, I4 obtain and I5, I6, I7, I8 obtain. The waveform of non-sinusoidal current is given. Although the wave is sinusoidal, it is still cycle and symmetrical about x-axis. So the average value of the current over a complete cycle is 0. The average value of a current over a complete cycle is 0. That is very important. Mean value, that is, or average value is. Graph shown in figure. Hence, consider only the half cycle. First half cycle consider I average is equal to I1 plus I2 plus etc. plus I6 divided by 6. AV is average value. Graph shown in figure, that is time versus EMF. E is already, we learned E is EM sine theta. E average is 1 divided by pi integral of 0 to pi EM sine theta d theta. EM divided by pi minus cos theta 0 to pi. E average only we find 2 EM divided by pi. That is formula, very important. That is asking 3 more questions and answers. That formula based problem. EM value is given. Find out E average value. Effective value or root mean square value or RMS value. When a current of I ampere flows through a resistance of 4 ohms in power loss is P is I squared R, that is power loss, so many watts. Therefore, if the current I1, I2, I3, etc. flow through the resistance R for equal time intervals, then the average heating effect over a half cycle we get a formula. Power loss is I squared R plus I squared R plus etc. I2 squared R plus etc. plus I6 squared or divided by 6 for off cycle. X is I1 squared plus I2 squared plus etc. plus I6 squared divided by 6. If the direct current of I ampere flowing through the same resistance or for a off cycle produces the same heating effect, then I is said to be the effective value of the alternating current. I is root of I1 square plus I2 square plus I3 square plus etc. In square divided by n. That is second equation. That is very important equations for find RMS value. From two above equation, it is seen that I is root of the mean of the square of the current. Root of the mean of the square of the current I is. That is important. Above second equations and root of is important. Hence, it is known as root mean square value of RMS value of current. Therefore, the effective or RMS value alternating current or voltage is the value of direct current or voltage that produces same heating power in the same resistance. RMS value that indicates I. Capital I. Note, heating effect for the negative off cycle is also positive. Hence, the RMS value can be computed by considering either one off cycle or full cycle. That is small I is Im sin theta, small I is Im sin theta. Full waveform is shown in figure, graph, time versus current. IRMS squared is equal to 1 divided by 2 pi integral g 0 to 2 pi Im square sin square theta d theta. IRMS squared is Im squared divided by 4 pi integral 0 to 2 pi 1 minus cos 2 d theta d theta. Formula slightly given. Only we find out IRMS squared is Im squared divided by 2. IRMS is Im divided by root 2. From this way, we obtain ERMS as EM divided by root 2. IRMS root means square. IRMS is equal to IM divided by root 2 and ERMS is EM divided by root 2. That is important formula. That is asked in 3 more questions and answers. Peak factor, maximum value divided by RMS value. For a sine wave, EM divided by 2, root 2 is 1.414 voltage value. IM divided by root 2, that is current value. Form factor, RMS value divided by average value. IM divided by root 2 divided by 2IM divided by pi, that is current wave. Form factor is equal to pi divided by 2 root 2 is equal to 1.11. 1.11. Form factor is 1. That is very important. RMS value is divided by average value. Peak factor is maximum value divided by RMS value. That is sine wave value 1.414. Form factor is 1.11. That is very important. That is AC circuits for University syllabus unit 1. Dote syllabus for unit 3. Kindly noted and use this video. Thank you.